Okay, I've started recording. Okay, write down the topic for today will be binary systems. I don't know what that is. Okay, binary systems. Okay, the first type of system is called decimal systems. Take notes, okay, very important topic, binary systems. Okay, does anybody know what is decimal system?
Number system having base number 10 is called decimal.
Yeah, very good. Write down. Decimal system is basically numbers in base 10. So what does that mean? It means you have basically have 10 digits to make your number system. And we humans use the decimal system. So the thing is, you have these 10 digits and you have to build your entire number system. So what should be the next number? Everyone knows after 9 is 10. Why is that? Because the single digits are done. You take the biggest digit and attach the lowest digit to it. So the next digit is 10. Try to understand the concept. What should be the next one? You take this number and attach it to itself. So you get 1, 2, and then 1, 3, and when you reach 1, 9, will you attach 1 to 10? No, what you do is you go to the next digit and attach. So the next number is, and so on. Is the concept clear how the system is made? Are you in this class? You just want to sit? Okay. Okay, so the second system is called the octal system. What base is this? 8. Write down. Octal system is base 8. So what all numbers should you have? 0, 1, 2, 3, 4, 5, 6, and so what should be the next number? 8. The next number is? So you have this system. What do we get after 9? So what should we get after 7? We should get 10. Does that make sense? Because the digits are over, you take the next biggest and put it next to it. So what should be the next number? This should go up till what number? 17. Does it make sense? Very good. So after 17, what should you get? You're done with 17, so you have to move on to 20. So the next number is 20. Is the concept clear? So now if I tell you, yeah.
Is it after 20? The 20 is after 17.
That's right, in base 8, not in base 10.
So
Even though you see 20, it's not really 20. It's 20 in base 8. So if I ask you this, so this is how we write it. I say 10 in base 7. Sorry, base 8 is what in base 10?
8.
Right? 10 in base 10, base 8 is 8 in base 10. So if you see a number next to it, this will say this is the base. Does that make sense? Any questions here? So the main system we are interested in is the binary system. So binary system is what base? This is base 2. So what are the two digits we have here? 0 and 1. And what are these digits called in computers?
Switch.
Bits, right? And they're called bits. When we did logic gates, they were the on and off signals. But in mathematics, they are bits. Okay, tell me at least the next few. What should be the next one? 1 0. 1 1, very good. Then
0 1.
0 1 is just 1.
1 0 1 0 1 100.
1 0 0. Does that make sense? Because after 99 you get 100. So take 10 and attach 0, take 10 and attach. So the next one should be what should be the next one?
1 1 0.
Very good. 1 1 1 1 0.
And 1
1 1 1. Let's do one more.
1000.
Very good. The next one is 1000 directly. So if you think about it, 1 2 3 4 5 6 7 8 9. So 1000 is actually, so when you're in your computer, when you press 9, the computer understands 1000. Okay, so if you press a big number, you can imagine how big the bits get. So that's what we'll try and study. How does the computer understand your inputs? But before that, let me see if I can study a little bit of mathematics. Okay, so now the next question will be converting from decimal system to binary system. Okay, so if I give you a number Let's do an easy one first. Okay, try to do 35 base 10. Okay, tell me the binary number here. 35 in base 10 is what in base 2? How do you do it?
By dividing by this of binary.
What do you do?
By dividing with this of binary.
Very good. So what you do is you take the number and divide by the base. 2 times what takes you closest to 35?
2 times 13. No, 18. 18.
17. How much do you get?
1001.
34, right? And the remainder is? Whatever remainder you get, that becomes your last digit.
So
1001?
1001.
Okay, let's see. Does that make sense? How did that one come? Then take the 17 and divide again by 2. 2 times what takes you closest to 17? So you write down 8 here. 16. What is the remainder? So your next digit is also. So let's finish it. Take 8 and divide by 4. 8, 0. So what do you get? Then take 4, divide by 2. I finish this. What is it? Final answer? You get 10011. So it means 35 in base 10 is when you type 35 in the computer understands 10011. Okay, because the computer only understands binary code. Any questions here? Try one more. See if we can do it. Try 278 in base 10. Okay, try and do this 5 minutes. get?
Zero.
Zero? Yes, keep going.
0,
Oh,
1,
oh,
0,
oh.
1, 1, 0. 1, 0, 1, 0, 1, 1, 0.
Okay, I'll write down the answer, see if you get that. It's 1, 1, 0, 0, 0, 1, 0, 1, 1, 0. Got it? That's the answer. It is getting recorded, so when you're watching, you can skip this wait time, yeah? Just go ahead. Okay, everyone get this? Yes. Move on. You can practice this when you practice. Okay, let's try the other way now. Should we wait or should we move on? Let's do the other way. Convert binary to decimal. I look here, you can practice later. Let's see the other way. Convert binary to decimal. So now, for example, if I give you 1001 in base 2. And the question is, convert this to base 10. Okay, try and do this. Question is, I give you the number in base 2, and you want to convert it to base 10. How do you do it?
Multiplying the base number with the value of which place value we have followed LCM.
Yeah, very good. Yeah?
LCM we have
No LCM. Any other ideas? This is what you do. Whatever number I give you, you write it far away from each other. Now, what is the base here? 2. So the first number you multiply it with 2 to the power of 0. Then put a plus. What should I multiply this with? 2 to the power of 1. Because this is 0th place, this is 10th place, 100th place, and so on.
we start from right side.
We start from that side, power 0. Plus, what should this be? times 2 to the power of
2.
and plus 2 to the power of and then simplify. What is 1 times 2 to the power of 3? 0 times anything is? The answer is 9 in base 10. So make a note. The computer reads this and then it sends this to the software. And the software makes it back into 9 and puts it on the screen. That's the process that goes on in the computer. Okay, try one more. Any questions here? Try one more. It's not difficult if you get it. Okay, try and do this. 1 0 1 0 1 1 1 1 0 and base 2. All right, 5 minutes, tell me the answer. How much? No, it's 174. I'm getting 174.
Oh, yeah, 174.
Okay, this is nearly the last class. Does anyone really want to come on the screen and do the problem? No. This will help you for your presentation skills when you go to work.
So what will be the number?
That is the number. Try to solve it.
Okay.
Write it down first, yeah. It's right there, small.
I don't know how to use
It's okay, I'll show you.
Okay.
Write down 1, yeah. Write it far away from each other. It's okay, just hold on. If that happens, touch this and touch that.
Can I get a new space like a little more?
Hold on. Okay, do it here. Do it to the pen again. Yeah. Okay, explain to the class. Look behind and explain.
So guys, we will just make it separate to make sure we calculate it in better way.
Yeah, very
It's
good.
not a rocket science. We do it to solve it in a better
When
way.
you talk, you look behind. You don't look on the screen.
Yeah.
It's okay.
Sure.
You're learning. Yeah, very good. This should be step one. Spread out the digits.
So guys, this is the step one, and we split all the digits, and then we start with the base 2, which we have to solve. So we multiply this with the power of 0, 2 with the power of 0,
Yeah, very good.
and then we do 2 with the power of 1, 2, 3, 4, 5, 6, and 7.
Yeah, very good. Any questions?
No. Yes, because you already knew that the previous calculated digit was 9, where you've got 2 to the power of 3, you can just write 9 below there. Then whatever the remaining numbers you have to calculate, you can just add that to 9.
Yeah.
So instead of calculating all the way till 2 to the power of 3, you already have 9. On the previous examples, you can just write plus 9.
No, but this is not 9. No, this is not. Oh, is it the same?
From the previous example.
Yeah, it's the same.
Yeah, you can add that to 8.
But was it 1110? Oh, I think it was 1001. So it
That
wasn't
was the
9.
last number. That wasn't the
It wasn't 1110. 1110 is not 9.
Okay, but because you have till 2 to the power of 3, I thought that you could add that to 8.
No, but if this was 1001, you could do that.
Then you get the same number.
Yeah, but this is not 1001.
Okay, so you get a different number.
Yeah, you get a different number.
So in that case, we start from left, like we do calculate from the left. So if you feel like it's difficult task to solve this 2 to the power 7, what we do like this. Oh, sorry.
It's okay, yeah. Okay.
Do like this. If you guys remember from your childhood lectures in your school time, 1, 2, 3, 4, 5, 6, and 7. 2 2s are 4, 8, 16, 32, 64, and then what we got? 128.
128.
Are you sure, guys?
Yes, sir. Yes, sir.
So we got 128 for the first one. Erase. Sweet. Sorry guys, I'm new teacher here, so
We will adopt you.
so this you just say 0. Here you still have to calculate 60, 32.
22, sure?
Yes.
I'm trusting you guys. Oh. What's happening? Sorry. $16.
8.
8 will be 8.
Who said 16?
Eight plus 4
Oh, what?
plus 2. See, not easy.
Being a teacher is not easy.
The answer is 174 in base 10.
This is how we solve.
Okay, well done. Any questions? Should we move on? Okay, next thing. Okay, the next thing will be adding binaries. Okay, so the question will be, do 1001 in base 2 plus say 1, 1, 1, 1 in base 2. Try to add these two without converting it to decimals first. Directly add them. So just put them.
The answer would be 1, 1, 0, 0, 0.
Hold on, let everyone try.
Double 1, 0.
1, 1, 0, 0, 0. Let's see. Yeah, how do you do it? Let's see. What is 1 plus 1? 2, but it's what it is in base 10. So you write 10. Make sense? Then 1 plus 1 is 2 again, but it's actually base 2, so it's 10. 1 plus 1?
2.
10. And 1 plus 1 plus 1 is 3, but that in base 2 is? What was 3 in? No, 11, right? So,
Once again.
once again, we'll do one more.
So, sir, isn't it 10, 0, 1, then 10?
0, 1, then?
10. And then 0, 1, and then 1, 0, and then 1, 1. And then 1, and then we do 100. And then
Yeah, so 3 is 11, no? No, 2 is 10.
0, 1, 1, 0, third one, third.
0, 1.
That's 2, and then 1, 0. 1, 0 will be the third.
No. So this is 0, this is 1, this is 2,
Oh,
this is 3, like that. 0 is 0. 0 is not 1. Okay, let's try one more. Okay, try and do 1, 0, 0, 1 plus 1, 0, 0, 1, 0. Try and do this the same way. It should be simple once you get it.
One, 0, 0, 1, 1.
1, 1, 0, 0, 1, 0. 1, 0, 0, 0, 1, 1.
1, 1, 0, 0, 1, 1.
1, 0, right? 0, 0, 1, 1. Yeah. Okay, who wants to come on the board now? Quickly. Somebody else? Yeah, very good. Just write carefully, okay? It'll just slowly.
So everyone, this was actually simpler than the last example because we're only adding 1 and 0 mostly here, and we know that 1 plus 0 is 1, and 0 plus 1 is the same combination as 1 plus 0, so that's also going to be 1.
Yeah, very good.
And 0, 0, 0, 0, 0. So 0, because these are the exact same combinations. It's not like 0, 1 and then 1, 0. These are the exact same combinations. So they both equal 0, 0. And 1 plus 1, we know that equals 1, 0, not the opposite. 0, 1, it equals 1, 0. So just to elaborate here, 1 plus 1 in binary, that equals 1, 0. So we write that again here like 1, 0. This is the final.
Very good. Well done. So this is base 2. Make sense? Okay, that'll be the first topic. We'll do one more, a little bit more theory.